On practice exam 6 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. We have a gallon of paint which covers 400 square feet, and we're going to paint a rectangle. The rectangle can be many different aspect ratios: 20 by 20, 10 by 40, 40 by 10, 5 by 80, and that's what's plotted in this graph. So if the width is 20, the length is 20. You can read it right off the graph. If the width is 10, then the length is 40. 10, 40. Part A asks, draw a good tangent line at the point 10, 40, right here. Let's start by identifying the point. Then we'll draw a good tangent line. The rise, it actually goes down, is minus 80 feet. The run is plus 20 feet. That's pretty straightforward. So the slope is minus 80 divided by 20, which is minus 4. That's part A. Now we're going to get a very good estimate of the slope of the line by getting 2 points on a line very close to the point. Now it doesn't say which points to use. We can pick the points. We're going to get the slope of this line by picking 2 points close to width equals 10 feet. That's part B. So here's the normal equation, and we can pick whatever points we want. Let's pick these two, just to show that you can do anything crazy, as long as they're close to 10, and they're close to each other. So we're going to go W equals 10.003. Both of them are bigger than 10. Normally you would go around 10 evenly, but it doesn't matter, because you're so close there, the line is straight. Okay, so if the width is 10.00034, we can calculate the length. And we go a little bit further, and we get a different length. The rise is the change in length, and the run is the change in width. The change in width we can calculate because that's given. We just picked it. It's 0.0003. To get the delta L, the rise, we have to subtract these two lengths. So we do that, and then we get minus 0.001199. The run is the ones we chose, 0.0003, and we divide those, and we get, not surprisingly, minus 4. Really close to minus 4. Minus 4 to 3 significant digits, minus 4.00. Not surprisingly. So here's the same function plotted near this point. So if you want to get the slope of this line, it looks straight at this scale, so we can pick any 2 points we want. This one, this one, this one, this one, this one, this one. We're going to get very close to minus 4 for the slope of that line, because it's straight. At this point right here, the slope is exactly 4, because we can calculate it. On to part C. So let's get the difference equation, and then calculate the slope at that point. That's the normal equation. We're going to change L by delta L. We're going to change W by delta W. So there's the difference equation, and we're sticking it at 400 square feet. It's a gallon of paint. That's what it will cover. So multiplying this out, we get this, and we know that LW is 400 square feet. So we can subtract that from both sides, and we get this. And this tells us that if W goes up, L has to go down, because we got a 0 here. If they're all positive or all negative, there's no way it's going to be 0. And it should make sense. So we have a nonlinear term. It's got 2 changes in it. Let's drop that nonlinear term. So we just have this nice equation. So we got to solve for the slope, which is delta L over delta W. And we can do that. And this is the expression we get. We have L over W, and we can plug in LW equals 400 square feet. So now we just have an expression with W. And we know W is 10. We want it at 10. What's the slope at 10? So we stick in 10 here, 10 feet. We square it, we get 100 square feet. 400 square feet divided by 100 square feet is -4, as we expected.